Okay, so today or now I will I will be solving a Leetcode contest for 18 weekly. Just sign up for that. Let's open all the tasks. Oh, I don't already don't like it. GCD. No, nice. So it looks like I should somehow greedily go from left to right for every number and kind of check if whoever has like ones in the beginning and then move that further, like use that number first and then that's gonna be the first number and then the second one gonna be whatever is left. I wonder if I can do some kind of check if I'm recording. Am I recording? Really hope so. I'm recording. So my idea is here is to do some kind of so 2 here is 1 0, 8 is 1 0 0 0, and 16 is like 1 and 4 zeros. And because can I even order it somehow? Oh, I probably can order them and then gradually add them. So ordering gonna be the following. I need to so int n equals mass log 2 divided by the mass log n1 mass log num1 over num2, and then I need to convert it to integer and do the same, and then 2 equals this one, and while n1 greater than equal 0 and n2 greater or equal 0. I'm gonna check if n1 and 2 1 and 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 how to shift? I need to shift to the left. Shift bit to left. Java. Okay, 1 and then shift n. 1 and then n1. So what gonna be, let's say, 7. 7. So it's gonna be, I need, if I gonna have 8, 3. So to represent 8, I need 3 bits. 3 bits or 8, or even more, or 4 bits. That's weird. Probably I need +1 here. Or like 9 or 16. Okay. Okay. And to the 1, and then I need to do what? 1 equal 1. Num, let's say, to num1 bit. Int num2 bit equal n2. And okay. Num1 and here num2 and 1 to the n2. let's do this one. Four. Okay. One bit not equal 2 bit. If num1 bit equal 1, then return -1, else return 1, and then and 1 plus plus, and 2 plus, and 1 minus minus, and then and 2 minus minus, and then if they are equal, I will do nothing. And then in the end, if num and 1 equals 0, a and 2 not equal, not 1 not equal 0, and not 2 equals 0, then I need to return -1, or else return 1. So this is gonna be our comparator, and then I need to do what? Concatenate numbers to get the results, which is representation. Okay, then I need to concatenate them. So for int I equals 0, I less than n, num's length, I plus plus, and then res equal int res equals 0, and then res okay, int n num, okay, int n equal num let's say 4. Let's say we have like here 4. So 4 is 1 on 0 0. So log 4 over log 2 gonna be 2. This one's 4 like here. So if I gonna move 4, how many times? I know, look, 3. So this one gonna be 3. So if I gonna move 4 3 times, so I need to okay, I need to move. If I move 1, 2, 3, 4. Okay, 4 times, so I need to plus 1, add 1. Okay, what's happening? Okay. So I need plus 1, then pew 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 result, and then n is equal log nums e over log 2, and then here int the next plus 1, and then I'll need to res equals res move n times, and then make it or nums e, and then return result. Here sort nums, No, still bad. Why it's so bad? Um, integer, okay. No? What arrays sort? Array sort integer. What in the world? Oh, Java array sort int custom comparator. Okay, let it be. Oh, like, can I do this one still? I wonder. Run, run, run. What in the world? How to write custom comparator? So this and I, so it should be not a flat arrow. And let's go with this arrow. Not a fat error. Okay, now we are talking. Int math log. So 18 and 27. What I got for the 18 and 27? Okay. 18. So one. So it's gonna be. This is 18 and 27. So what should be in this case? And 18, 27, and 1. So 1 gonna be just 1. 18, 27, and 1. So here gonna be, what should be go first? First should be 1, then 27, then 18. In this case, you're gonna have 1, 1, 1, and then 0, 1, 1, and then 1, 0, 0, 1, 0. Otherwise, it's gonna be less. if I put a one, I will not never get the 3 ones in the beginning. Okay, so let's print it out. What it prints? Whether I made any mistake. Um, let's use this case. How many people already sold it? Oh, a lot. 4 int I equals 0, I less than n. Let's say nums length I plus plus system out print nums I 1, 18 and 27. And it should be 27 and 18. Why? What if I do this one? No, it doesn't change. What if I flip it like this? This one and here one minus. Save? Oh no. What the problem? Oh, it's completely reversed. So something is wrong with this algorithm. There is some error there that I cannot see. Why? Where is it? So I'll probably be able to do something like this. Mm. Let's copy this one to function. Um, int num1 18 int num2 equals 27 4. Let's say copy all this. Um, system out print, say break here and then break here then okay, do here print, let's say print num1 num1 bit plus num2 plus num2 bit print ln. Let's try to execute this one. Okay, let's run. What? 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 Okay. Can you do this one? Separate scope. Okay, system out println. Ah! Okay, let's try to cut this. Then let's cut this together. Still no. Why? Why is this happening? Okay. 219, 111, 5, and 111, 5, 11, 11, and then 5. Okay, say mistake. 5. 5 gonna be 101, and then 1 gonna be 1. So, in this case, what should be the answer? The answer should be 1. So 1, and then what's bigger? 1, 1, 0, 1, and then 1, 0, 1, 1, or 1, 0, 1, 1, and then 1, 0, 1. Okay, so I got it. So this one, how we should treat it? How I should treat the connections? So in this case, I'll have the one and then I'll select first 5, 11, where while I should have selected first 11 and only after that. So if I choose 11, if I choose 5, 5 and then 11, this number gonna be less than if I gonna choose 11 and then 5. Um, how I can put 11 before 5? I said this algorithm should work, but there is a counterexample here. So the counterexample is always like long number with all ones. Not exactly, not ones. So here, because I run out of numbers from 5, I tend to select it to give it more priority to 5. But I should be giving priority to 11. I wonder if so I'm basically comparing 101 and 10, 11. Okay, so if I ran out of numbers for the here, this is not else. You can take like this, yes. So if I'm running out of numbers, I should still check the If there gonna be zeros in the end, I'm wondering if one gonna have zero in the end and another one gonna have ones in the end. Mm. What about this? Oh no. What should be the target there? Okay, let's run this one. Back that even worse. Because I'm gonna stop selecting one in this case. Uh, 101 and then here 101. Yeah, that's difficult. 101. What's the key problem here? The key problem here is that because there is kind of a run out of numbers, I have different sizes for there. So it's kind of I should start comparing from the middle of the number. Some kind of that logic. How to deal with this problem? Um, so um, it's not obvious what should be used. Ah, okay, okay. If in the end we have only what? Ones, but again, this one can hurt me. What did I change here? This is hurt me, hurt me. Don't move. That became even worse. Num1 not equal num2 bit. What did I change here? I change or. Okay, so I change it to and. Okay. So I need to check if the n1 next n1 is 1. Huh? And 1. Yeah. If n1 not equal 1. If n1 if num1 bit if it's equal to 0. Oh, that's a bug. If I ran out of that one and this one is not run out of, then I need to return -1. And here, if num
There's tape and scissors on my porch. Can you get them? Dad, there's tape and scissors on my porch. Can you get them? Dad. Yeah.
if I just return this, T. Uh, One, two, three. What's the problem with one, two, three? So we have here 1, 1, 0, 1, 1. This is 1, this is 2, this is 3. So if I concatenate it, so there are two representation. Okay, one. So it should be either 1, 3, 2 or 3, 1, 2. What it will bring here? 4 and I equals 0, other than n, I plus plus. System out print on. Okay, let's do that. So it gives me 3, 2, 1. Why? 3, I understand why 3. Ah, still. 21, 29, should be 30. If it's greater than 0. It doesn't make any sense. Yeah, this custom check doesn't make any sense. I don't know how to solve that one. Let's move to another. What the hell? Okay, so it's kind of connections. So it's kind of figure out what's the connected components. Um, so I built the graph. There is k, that's a buggy method, and I need to kind of figure out. Uh, so so I need to do this BFS kind of stuff, or like DFS, and flag all the methods that um, that are kind of invoked. So I need to go. Um, is it like building reverse graph? So if there is a cycle, I definitely cannot remove anything because, yeah. So here k gonna be removed. K equals 1. 1 to 2, 0 to 1, 3 to 2. Okay, if I gonna remove k equals what? But 1 was suspicious. Why it was removed? Why it wasn't removed? Method 2 and are suspicious, but they are directly invoked by method 3, which are not suspicious. Return all elements without removing. Okay. Mm, what? What everybody knows that I don't know here? Ah, they just what? I thought it was a general case. Oh no. I thought I should solve it in general case. Oh no, that's bad. Okay. It's bad. 4 int I equals 0, I less than I plus plus. Yeah, I don't wanna try this right now. From the project, yeah. So all combinations. How about this one? sort nums. How about that? Um, I don't wanna do that. I don't like it that I wasn't able to solve it in general case, but let's move on. Mm. That's a weird explanation. So, should I just go DFS and then let's have hash map integer hash set integer g equals new hash map for int h invocations, then g get or default in 0 new hash set hash set integer as equals this one, and then dot add e1, and then that put e0 to then set, and then boolean like hash set integer bad equals new hash set, and then bad and k, and then um, let's say q to visit new linked list, then here integer, then to visit add like offer q, then while q q the not is empty. Well, it's not empty. I'll do q dot poll, then integer int v, and then for hash set integer s equals g dot get v, if s equals null, continue, otherwise set for in int next in set. I'll do if bad contains, not contains s, then I'm gonna set add q dot offer s, and then bad dot add s. That's gonna be bad nodes. So now I need to go through each vertex and figure out if it's in if it's connected, if it's eventually connected to the to any bad node from the set. I don't understand. There is no method outside the group invokes. What is the group? I wonder if I can calculate the number of in degrees for every node. So for this node, the number of in degrees gonna be 1, and for this node, the number of in degrees gonna be 2. And then um, um, pu- 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 and then I'll start removing in degrees by just following this pattern. And then if I complete this removal of the in degrees and all these nodes, okay, um, so let's modify it a little bit. Mm, map integer degree. Degrees is gonna be a number of connections coming in the integer hash map, and then hash map degrees get or default. Okay, get a default and then e1, then 0 plus 1 degrees, put e1, this one. Then I'm gonna go and create the bed nodes, and then I'll do the following. I'll remove the degrees. I'll follow up and next. Okay, then degrees uh, get or default e get next and the next, and then I need to decrease it. Degrees dot put next minus 1. Next, and then in the end I need to go for int I fourth int v in the bed if degrees get v equals not equal 0, then break, and then return full boolean, return full equals false, and return full equals true. Then if int what I should return um, list integer result equals new array list um, for g dot for g int v g dot key set if return full, then um, result add v, or else result if v bad contains v, if it not contains, I need result add v. So return result. So hash map new hash map. If degrees get v equals null, then what? Then continue. What? Okay, that's a bad day for me today. Not available output. Turn full. System out. Print ln return full. Return full. Key set. Okay, let's add the edge. G get of default hash set integer set to G get or default E1 new hash set degrees put E Oh no, 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 no. No. Um, it's the same as 2 e1, and then g dot put e1 is to run general through. Okay. For int I equals 0, I less than n, I plus plus g dot put I new hash set degrees put I 0. Oh, at least one. Um, how I can possibly solve that within 2 minutes? Solve this task within 2 minutes. How is it possible with this current implementation? So what I need to do, int nums, how to solve it quickly. I need to um, create all the combinations and then concatenate them, and then user are just 3 numbers. Some, let's say, private void bt int nums. Yeah, I cannot do that fast. Okay, so let it be this way. Yeah, a little bit fail. I'm gonna stop recording.